Okay, this is Coach Williams, and we are going to go over 7.6, 7.7 notes. This section is still factoring polynomials, but in this case we're going to factor a trinomial, and for the most part we're going to factor trinomial into two binomial factors. So let's get started. There's not a lot of notes to this really. There's just going to be an example of the method we're going to use, and just a few reminders of the form that we need to have this in before we start, so on and so forth. So let's get started. First of all, we want to make sure that our polynomial is in the form of ax squared plus bx plus c. And these letters just represent the location of the terms. Okay, so this is the location of the terms. This is the first term, the squared. This is the second term. Thus, A, B, going in order of the alphabet here. And then C is the last term. And so we want to make sure that they're in this order. And we're talking about polynomials where A does not equal a 0. Okay, so it does not equal 0. This is the form that we want it to be in. And again, the A, B, and C are placeholders. A, B, and C are just my placeholders, and not necessarily the variable that we're solving for that's in the polynomial. If you'll notice in this first one, there's a little confusion when we do this example, because when I say, well, what's the C? Well, oh, coach, there's a C squared and 8C. It's not referring to the C that's the variable. It's talking about the C that is the placeholders in those locations. All right, so now, how are we going to factor these trinomials? And that's a good question. So I'm going to answer that question for you with this. We're going to use this large X. We'll do a little smaller one when we get to the problems. We're going to do this large X. And the top, what we're going to do is we're going to put certain terms around in the spaces of the X here. And what we're going to do is on the top, we're going to put the A times the C term. Sorry, A times the C term. So it's going to be A times C. Okay? In the bottom, we're going to put the B term, and that's kind of easy to remember because bottom starts with B, so we put the bottom term will be B. And then we're just going to I'm going to give you letters here for some constant. And normally when you see in math and science, you have a constant, some constant. They use K to represent constants. You'll probably see this in other classes as well if you haven't already. And then you'll have some other constant. We'll just call it K sub 2 there. So we have constant 1 and constant 2. And what is special about this is that we're gonna see that these two here have a relationship to the top and to the bottom. They multiply together to make the top, and they add together to make the bottom. Okay? So in essence, this term right here on the top is K1 times K2. And the term on the bottom is K1 plus K2. And you may end up with one of these being a negative or both being negatives, but basically you're adding those terms together to get this bottom term. Okay, so that's the concept of the X here, and setting this up so that we can find out what the factors are. So now, when we have this set up, and we have the condition when A equals 1, all right, the factored form, or the answer that we're looking for, the factored form when A equals a 1 is going to be, in this case right here, it's going to be X plus K1 times X plus K2. And that's it. That's how easy it is. We're making sure, though, that when we're looking, we're seeing that A is a 1, and the factored form, the answer will be this right here. So basically, once we find the two numbers that multiply to be this top, and that add to be the bottom, then we just take the x and we add the k to it, and we multiply that times x, adding the k, the second k to it as well. And again, we'll see this just a second in an example as we move along here, but that's the basic concept. We're going to come back and add to this in a minute when a does not equal 1 and can't be factored out. I have a question, yes. Okay, you need to get where you can see it. All right, so on number 1, let's look at this as an example using what we've learned so far here. Okay, so we've got, first of all, we need to identify our terms. We've got to identify our placeholders here. And so we need to find out what A is, we need to find out what B is going to be, and we need to find out what C is going to be. And again, C is not the C that's inside here. C is the placeholder for this location or this term, the third term in the polynomial. So what is my value for A in this polynomial? It's 1. Okay. And then what's the value for B? And that's 8. And then the last one will be, the C will be a 7. So those are my 3 values that I need to identify when I first start to factor this. And then the rest of it's really pretty easy. Okay, so let's draw the X. And inside this, I'm going to put, the top is going to be A times C, or 1 times 7, which just ends up being 7, right? So 7's my top term. And then the bottom term is just B, which is an 8. And now I'm looking for the factors of 7, which there's only 2 numbers that we know of, that because 7's prime, there's only 1 and 7. So we know that those are the only 2 factors. But I'm looking for factors of the top number that when you add them, they become the bottom number. And 1 and 7 are the only factors of 7. And so they have to be the answers for this one right here. And we're also looking for, because everything's positive, we're looking for things that add. We'll get to some negatives and things that subtract in a few minutes. But right now, everything's positive, so we're just dealing with what multiplies to be the top, what adds to be the bottom. So my answer in factored form will be real easy. I'm going to have C plus 1, right? C plus this number on the left, times C plus the number on the right. And that's it. That is the factored form of C squared plus 8C plus 7. And if you wanted to check this, you could just multiply those together, and you get those answers. You would get, if I multiplied C times C, I would get C squared. If I multiply C times the 7, I get 7C. And then 1 times the C, I get 1C. And so the 1C plus the 7C equal this 8C in the middle. And then 1 times the 7 will equal the 7 on the end. So, I'm sorry, the question is being asked, what is on top of what now? On top of the triangle here, we have 1 times 7, or just 7. 7's the number that we put up there. And we won't put the 1 every time because we know that the 1's just kind of understood. Okay, on to the next one. Let's identify our placeholders here, A, B, and C. And A is 1, B is 16, and C is 64. Again, we don't have to put the 1 in every time because we know it's going to be there. The top one is going to be 1 times 64, right? A times C. So we just put 64 at the top. At the bottom, we put the B term, or the B placeholder, which is going to be 16. And then we look at the top number, and what are the factors of 64? 1 is 64, 2 and 32, 3 doesn't go, 4 does, 16 times, 5 no, 6 no, 7 no, 8 yes, 8 times 8, and so, and then it just repeats itself going the other way. So which of these factors, obviously we know they multiply to be 64, but which of these factors add to be 16? 8 and 8, exactly. So I'll put 8 there and 8 there. This is all addition. Everything's positive, so everything's adding, so we're good. Now we can write our answer. A plus 8 times A plus 8. And there you go. Now you could say this. I'm going to put this in here. You could rewrite this as a plus 8 squared if you wanted to. Either one of those answers would be correct. Okay, not too bad so far. Not too bad. These are pretty easy. They get a little tricky when we get into some of the negatives, but not bad. And then a little tricky when we get into some of these polynomials where the a term is not a 1. But again, it's still pretty simple because it's a systematic process, and you just work your way through it and you're good. All right, on to number 3. On number 3, we can identify our placeholders again. And for A, it's still a 1. For B, it's an 11. For C, it's 18. Very good. If I draw my X, the top term is going to be 18. The bottom term is going to be 11. And then I'm going to look at the factors of 18 that would add, everything's still positive, so we're just adding, that would add to be an 11. So if you think about it, which two factors of 18 would add up to be 11? You've got 1 times 18. You have 2 times 9. Yeah, 9 and 2, exactly. So 2 and 9 would be my two factors. These two multiply to be the top one, add to be the bottom one. So now x plus 2 times x plus 9 is my answer. And we're done. It's as simple as that. All right, let's move on to the last term being negative. I've got a question here. Hold on. Yeah. No, and that's what we're going to look at. The question was asked, will A always be 1? And it's not going to be. And we're going to learn how to deal with it if it's not in the next few examples. For the next 3 examples, A still remains a 1. But we deal with some negative numbers, and so some of our terms for the k the k terms may end up being negative or positive, instead of being all positive. So we'll run into that. But when we get down to 7 through 12, we'll deal with situations where the a is not a 1, or the placeholder a is not a 1. Okay, so let's look at number 4. Number 4, we can, like we just mentioned, a still is a 1. B is 3, and C is negative 54. Okay, so now we're going to have to deal with a negative number. So let's draw the X, and let's talk about how to do that. The top is going to be a negative 54. It's my C times the A term, right? So it's negative 54 times 1, or just negative 54. And the bottom number is a positive 3. Now, when the last term is negative, if you think about it, in order to get a negative term here, you have to multiply a positive times a negative. Okay? If I had 2 negatives, that would make this positive. If I have a negative times a positive, that gives me a negative term at the end. So what I'm looking for now is 2 factors of 54 that subtract to give me 3. Don't worry about what's negative and what's positive yet, but 2 numbers that multiply to be a negative 54. But when you find the difference of those 2 numbers, I get 3. Okay, so let's look at the possible factors that we have. We have 1 and 54. We have 2 and 27. 3 and 18, I think. 4, no. 5, no. 6 and 9. 6 and 9. Okay, so 6 and 9 are factors of 54, and they add to be a 3. So if I do 6 and 9, I put those in here. They subtract to be a 3. And here's where you got to remember a rule. Okay, whatever the bottom term is that whatever sign of the bottom term is going to be the sign of the larger of your 2 factors. Okay, so if the bottom is positive, then the larger 2 factors is going to be positive. All right, so now, what we're going to do here is we're going to apply the negative. One of them has to be negative, so we're going to apply the negative to the smaller term because the bottom one is positive. The larger term has to be positive as well. So we're going to have B minus 6 times B plus 9. And that should be my answer for number 4. I found out that these two factors of 54, when subtracted, would be a 3. I applied the sign of the b term to the larger of the two, so then the other one had to be negative in order to get a negative 54, and then there's my answer for the factored terms in two binomials there to get to this trinomial. All right, number 5, let's look at that and identify our placeholders. So we have a 1 still for A, we have a negative 1 for B, and we have a negative 2 for C. All right, we'll draw the X. And at the top, we're going to have 1 times a negative 2. At the bottom, we have a negative 1. Again, I have a negative top term, so I'm looking at factors of the top term that subtract to be the bottom term. If that were positive, then they need to add to be the bottom term. In this case, they're subtracting. Not worrying about the signs right off the bat. There's only 2 factors of 2, so it's 1 and 2. Now we just got to figure out which one gets the negative sign, because the negative sign is on the bottom. We apply that same sign to the larger of the 2 numbers. So it would be the negative 2. All right, so now this is pretty simple. We're going to have y plus 1 times y minus 2. And that is my answer. All right, on to number 6. Do it the same way. We'll have my A, B, and C. I have a 1, I have a 3, and I have a negative 18. So I'll draw the X. And at the top I have a negative 18. At the bottom I have a positive 3. And now what 2 terms multiplied would be a negative 18? Because this is negative, I need to find out what those 2 terms are that would subtract to be 3, or the difference of them would be 3. And 6 and 3 is a good answer. We know that the difference of those 2 would be a 3. We need it to be negative. This is positive, so this has to be the sign of the larger term, so the negative has to go on the 3. Okay, it has to be a negative times a positive to get to the negative, and obviously when we add these 2 together now, negative 3 plus a 6 will be a positive 3. All right, so we'll have u minus 3 times u plus 6, and that is the answer for number 6. Okay, we're going to move into having an A term or placeholder that is not a 1. But on this first set of 3 problems, we're going to have the option to factor that term out, or that placeholder out. Okay, so when I'm looking at this, I'm saying, okay, can I divide everything by the A placeholder? And in this case, I can. And if that's what we're presented with, then we just factor the 2 out. So we put it out front, and then we get the resulting polynomial, and we will apply our factoring method to that part. So that would give us a c squared, and then 14 divided by 2 would be 7c, and then we're minusing 36 divided by 2, which is 18. Okay, so that's what we're looking at now, and we can factor this trinomial, and we're going to end up, I'll write this first right now, we're going to end up just bringing our 2 down in front of our factored form for this trinomial. So with this part done, let's go ahead and identify the A, B, and C of this form. Okay, we're doing it for this part, and that is a 1, a negative 7, and a negative 18. So when I draw my X, I'm going to put a negative 18 on the top, and I'm going to put negative 7 on the bottom. So now what factors of excuse me, what factors of 18 will be a difference of 7? And 9 and 2 is what one of the students here is saying, and that is correct. It's going to be a 2 and a 9. 2 times 9 is 18. and the difference of 2 and 9 is 7. And again, we look at the bottom term. It's negative, so we have to put the negative sign on the larger of the two factors. Okay, so don't forget your 2 when you bring this down. Okay, don't forget the 2. So we're going to have 2 times C plus 2 times C minus 9. And that will be your answer, factored form for number 7. C plus 2, C minus 9. Okay? All right, for number 8, again, we have a 4, or something other than 1, in front of the first term, so my A placeholder is not a 1. And that being the case, we look first to see, can we divide it out of everything? And yes, we can. So we're going to divide by 4 on every term. So that means we're going to pull the 4 out front, and then we'll have A squared plus 2A, and then minus 140 divided by 4 is 35. Okay? We will identify the A, B, and C for this polynomial. Okay? So we're going to pull those out of that polynomial. And we're going to have 1, 2, and negative 35. So we'll draw the X, and we'll fill in our values for the spots that go here. For the top term, we're going to have the 1 times the negative 35, or just negative 35. For the bottom term, we have our B, which is 2. And now again, because the top term is negative, we find out what factors of 35 will be a difference of 2. And 7 and 5 is a good answer. So I'll have 5 and 7 put in there. The value, or the sign of the bottom value, is positive, so that has to be the sign of the larger of the two factors. So I have to put the negative sign on the 5. And that makes sense. Negative 5 times 7 is negative 35. Negative 5 plus the 7 will be in a positive 2. So don't forget your factored out 4. We're going to have A minus 5 times A plus 7. And that is the factored form for number 8. And the question is asked if it doesn't matter what order these are in, and it doesn't. It can be 4 times A plus 7 times A minus 5. Remember that multiplication is commutative, so the order does not matter when you're multiplying. You can change or rearrange that order, and it's still the same answer, or resulting answer. All right, number 9. One more time, we can divide everything by the A placeholder, A equal to 5 here. So I'm going to pull the 5 out front. My resulting trinomial is going to be S squared plus 11S plus 10. And this one's going to be a pretty simple one. My A, B, and C, now that I have factored out the 5, it's going to be 1, 11, and 10. This is all plus, so this is going to be all addition, all positive numbers. I'll draw the X. The top is going to be 10. The bottom one's going to be 11. Pretty easy here. The two factors of 10 that add to be 11 are just 1 and 10. And again, don't forget your 5. 5 times S plus 1, S plus 10, and we are done with that. Pretty easy stuff. Again, once you get the hang of where things go, it's pretty simple. You just follow the process and you're done. All right, now the last part, I'm going to now add the second condition to the top where we did our notes. So let's slide up again and look right here. And now we're going to do something for when A does not equal a 1, okay, and it's not a factor of A, B, and C. Okay, so if we can't factor out whatever A is, If we can't factor it out of A, B, and C, then this is what we're going to have to do with it. Okay? We're going to multiply, like we talked about, the A times the C for the top number in our little diagram. We're still going to have B on the bottom. We're still going to have these two factors that multiply to be this product at the top, and they're going to add to be this bottom number. But when we write out the factored form, you're going to have to write it like this. It's going to be x plus whatever you found here, which will be the K1, and you have to put it over A. Whatever A is, you're going to have to put it over A. Okay? And then it'll be x plus the second factor that you found, all over A as well. And then, okay, then we will simplify the fraction. Okay? Simplify the fraction. And once the fraction is simplified, then our resulting factored form, and we'll see an example in just a second, the resulting factored form is going to end up being, we're going to take the A, okay, we're going to take this A out from underneath the fraction, and we're going to put it in front of the x. Take the A, whatever, if A changed to another value, that's fine. But if whatever this denominator is in the fraction, we're going to take it out to the front. And so then we're going to end up with AX plus K1 times AX plus K2. All right? So that will be the answer, and it may not be exactly K1 and K2. If it simplifies down, then obviously this will be slightly different numbers. But that's the format that we're going to look at doing. Okay, so let's do this. See examples. What is this going to be? 10 through 12. Okay, so see examples 10 through 12 below. All right, let's go look at some of these examples now. Like we talked about, we look to see if 6 can be divided out of every one of our placeholders, and it can't. We can't divide 11 by 6, we can't divide 4 by 6, and come up with whole numbers. So, we identify our placeholders. We have 6, negative 11, and then the last term is going to be what? Positive 4, right? For the C. All right, and then we're going to draw our x term, and on the top we're going to put A times C. Well, A times C is going to be what? 6 times 4, which is going to be 24. We still put B for the bottom term, which is a negative 11, and then we have our two terms that we're going to find here in just a minute. Okay, so the first part is not too difficult. We just don't have a 1 for A anymore. We have a 6. All right, now, if you'll look here, let's logically talk our way through this trinomial. We have a positive end term, but a negative middle term. What that tells me is that I had two negatives that multiplied to be the last term, but when I added two negatives together, they gave me this middle term. So my two terms that I have are going to be two different negatives, and because they're both negative, I have to add those together to get to this 11. They need to multiply to be a 24, but add to be an 11. Okay, we'll find that in just a second. But what two terms or products, what two factors of 24 will add up to be 11? And you have 1 and 24. You have 2 and 12. That you can't make those add up to be 11. You have 3 and 8. And that sounds like that's probably the one because 3 plus 8 is 11. You have 6 and 4, but that ends up being 10. So let's go with 3 and 8. 3 and 8. Now, the thing about this you have to remember is 3 and 8 both have to be negative when this top one's positive, because it takes two negatives to make a positive, but then added together they'll be a negative 11. Okay? So, you're still finding the factors of this product of 24, and you're still adding those together to make this negative 11. Now, the tricky part here is to remember that when we write this out, okay, the first step that when we write this out is going to be that we're going to take k, which is our variable in here, k minus 3 over a. What was a? A was 6. Okay? A was 6. The second term, or the second factor, is going to be k minus 8 over 6. Okay? And remember what our next step was to happen here. We need to simplify the fractions. So if we simplify these fractions, I'm going to rewrite this in different colors so we know that it's a simplified version here. K minus 3 over 6 is the same thing as 1/2. And 8 over 6 is the same thing as 4/3. Right? Divide that by 2, divide that by 2. Okay? So now that I have this part, now I can take the denominator of the fraction and put it out in front of the k and get rid of the fraction. So the answer now is going to be 2k minus 1. Okay, I took the 2 out from underneath, put it out in front. In essence, it's just like taking this factor and multiplying it times 2. If I multiplied everything by 2 in here, then it would put a 2 in front of the k, and 2 over 2 just becomes 1. Same thing with the next term. 3k minus 4. It's like multiplying this factor times 3. And if I multiply it times 3, well then it's 3 times k, and 3 times 4/3, and the 3's become a 1, so it leaves me with 4. Okay? And this gets us in a non-fraction factored form. Say that 5 times real fast. Non-fraction factored form. I'm not going to even try. Okay, number 11. Let's look at number 11. I can't divide 2 out of everything evenly, and so what I'm going to do now is go ahead and create the x. I'm not going to write these out to the side this time. I think by now we kind of know what we're doing. 2 times negative 9 for the top is a negative 18. The b term is a 17. And again, we need to look at signs. The top's negative. The bottom one's positive. I have to have a positive and a negative to reach this if I'm multiplying. So what 2 terms multiplied make 18, but the difference would be a 17. And that's 1 and 18. We should be able to pick that up pretty quick. The positive needs to be on the larger term because 17 is positive, 18 has to be positive, so the negative has to be on the 1. Now we've got to remember, though, we've got to put this over the a when we create our factors, our binomial factors. And so we need to have x minus 1 over 2. Remember, 2 is the a, so whatever this is, we've got to put it over a. And then the next term is going to be x plus 18 over 2. Now this works out pretty nice because this is the reduced form. Our fraction is simplified, this fraction is already simplified. So I can go ahead and put this 2 out in front of the x and get rid of the fraction. So it'll be 2x minus 1. And 18 over 2 just simplifies to 9, so we don't even have to worry about a fraction. This is just x plus 9. So 18 divided by 2 is 9. We don't have to worry about moving the fraction. We can just simplify the fraction to a 9, and we can leave it just like that. So this is my answer in factored form on number 11. All right, the last one. Number 12, again, I cannot divide all of the terms by 9, and so I'm going to set this one up just like we did the one before. I'm going to have 9 times 2, or a times c, for this top term, which is going to be 18. Everything's positive, so this is going to be a nice one to end on. 18 for the top, 9 for the bottom term, and factors of 18 that add up to be 9 because everything's positive. I'm just adding 3 and 6. And so I can start writing out my factored form, which is going to be W plus, remember this is not a 1, so we have to put the 3 over 9, and W plus 6 over 9. I'm going to reduce or simplify these fractions down. So this is going to be W plus 1/3 and W plus 2/3. And then I'm going to move this denominator out front. Move this denominator out front. And so my final answer, factored form, is going to be 3W plus 1 times 3W plus 2. Box that in. And that is the conclusion of our examples for 7.6, 7.7 notes. And you should be able to work your practice problems as long as you've got a pretty good grasp of the examples that we just went through. And that should give you a good head start. We'll see you guys next time, and have a great day.